Okay, let's put everything together into this problem right here. We have y equals negative sine of 2x minus pi over 3 minus 3. We can rewrite that as y equals negative 3. We can put that midline value up front minus the sine of 2x minus pi over 3. Both of those represent the same exact graph. Now we're going to need to factor out that b value so that we can get the proper horizontal translation. So when we factor that out, we get y equals negative 3 minus sine of 2, and then in parentheses, we're going to have x minus. When we factor out a 2, we divide out a 2. And when you take pi over 3 and divide by 2, it's the same thing as multiplying by 1/2, and that's how we get pi over 6. So pi over 3 divided by 2 is the same thing as pi over 3 times 1/2. And that's how we get pi over 6. So what we have happening here is we're going right pi over 6. The period is going to be impacted by the b value. So the period is going to be 2 pi divided by that b value of 2, which gives us a horizontal length of pi for each cycle, each pattern, each full pattern. And then we have this negative right here, that's a reflect over the x-axis. And then we have this negative 3 right here, and that is where our midline is going to be. It's going to drop down to y equals negative 3. So I'm going to highlight that one first. So I'm going to highlight that midline. We're going to have an amplitude of 1 because the coefficient of sine is 1 with that minus out front there. So our amplitude is 1. Let's write that down. Amplitude equals 1. And we have a reflect over the x-axis. And we have a translate down 3 units. Now this right pi over 6 is called a phase shift. So the phase shift is going to be positive pi over 6. Positive because you're going to the right. I don't think well, let me move that down because I think I might need a little bit more room. Put that back up there. There we go. Okay, I think I've got plenty of room now. Okay, so we've got our intervals, and let me explain how the intervals are going to work. We've got pi over 6. We know that we're going to go right pi over 6. So here's that right pi over 6. So that's where we're going to start at this pi over 6. The horizontal length is a length of pi. So this horizontal length is the length of pi. So pi later, that's going to be 4 intervals later, 1, 2, 3, 4. We're going to be at 7 pi over 6. So how did we get 7 pi over 6? You're going to take the period. The period is equal to pi. And you're going to divide that period by 4. And that's going to equal the distance between each interval. So that's going to be your interval length. Interval length. So if I'm starting at pi over 6, that's my phase shift. So that's where we start. We're going to add pi over 4. And if we take pi over 6 plus pi over 4, we're going to get 10 pi over 24. 10 pi over 24 reduces to 5 pi over 12. And you can see that that's the next, right there. It's the next interval mark. Then you're going to take 5 pi over 12, and you're going to add pi over 4 again. And that's going to give you 32 pi over 48, which is going to reduce to 2 pi over 3, which is exactly what we have listed. Then I have 2 pi over 3 plus pi over 4. and that's going to be 11 pi over 12, which is again what we have listed. And then when you take 11 pi over 12 plus pi over 4, we're going to get 44 plus 12 is 56 pi over 48, which is 7 pi over 6. Now when we go backwards, we're going to take pi over 6 backwards to the left is what I mean. So we're starting here and we're going to the left now. Pi over 6 minus pi over 4. That's going to be negative 2 pi over 24, which is negative pi over 12. And then we're going to take that negative pi over 12 and we're going to subtract pi over 4. And that's going to be negative 16 pi over 48, which is negative pi over 3. And that's exactly what we have. And then we'll take negative pi over 3 minus pi over 4. And this is where being able to add and subtract fractions is really what's happening here, getting a common denominator. We've got negative 7 pi over 12, and I believe that's what we have written there. And then if you take negative 7 pi over 12 and subtract a pi over 4, we're going to get negative 40 pi over 48, which will reduce to, let's see, 8's going to go into both of those, 5 over 6, negative 5 pi over 6. So now that we have our intervals labeled, and we know that we're dealing with the sine function, and we're going to start at the midline. So we're going to start at the midline. So normally we start at the midline, 2 pi later we end at the midline, but this case we're shifted right pi over 6. So right pi over 6, that's where we're going to start. Now we're starting at the midline. 1 pi later, we're going to end at the midline. So that's 4 intervals over. Halfway between, we're going to be at the midline. Normally between the first 2 midline dots, we're going to be at a maximum. But because we have that reflect over the x-axis, we're going to be at a minimum. So our amplitude is 1, so we're going to go down 1 unit from the midline, and then between the next 2 dots, we'll go up 1 unit from the midline. We're going to continue that to the left. So we're going to start at pi over 6 to the left. We're going to go 1 pi distance to the left, be at the midline. Halfway between, we'll be at the midline. Halfway between the dots at pi over 6 and negative pi over 3, where x is equal to negative pi over 12, we'll be at a max. And then halfway between the next 2 dots, we will be at a min. Let me try drawing this a little bit better. There we go. There we go. Fantastic. And that is our graph of y equals negative sine of 2x minus pi over 3, all minus 3. I like to write it like this, but you may see it either way.